let me take sodium. The electronic configuration of sodium is going to be 3s1. Now, I am going to teach you to write the condensed electronic configuration: lithium, sodium, potassium, rubidium, cesium and francium. Please write the atomic number very quickly. 5 seconds for you. Finished? You start counting now. 1, 2, 3, 4, 5. Write it, practice it. Three, 11, 19, 37, 37 plus 18, 55, 55 plus 32, 87 here. 2, 8, 8, 18, 18, 7. If you write it half a dozen times, you know. Now, the electronic configuration of lithium is going to be 1s2, 2s1. Now, it is okay because there are only 3 electrons. Supposing I have got 93 electrons. 1s2, 2s2, 2p6, 3s2, 3p6. You have to remember that ladder, you are likely to commit mistake somewhere there. If you just miss one orbital, the entire electronic configuration, instead of saying it's a p block element, you are going to say right incorrectly as a d block element, because if you are going to miss any one of the orbitals over there, that is a problem. So, we always we want to write the electronic configuration, we want to remember the electron present in the last shell only. Why? Whenever electrons have to be removed, electrons are removed only from the last shell. Whenever you want to add electrons are added only to the last shell. So, it is enough if you know the electronic configuration last shell. Therefore, we are going to know, we should know how to write the condensed electronic configuration. What does this stand for? 1s2, helium. When you say helium, it takes care of 1s2. After helium, you write 2s1. What is the electronic configuration of this? 1s2, 2s2, 2p6, 3s1, 3s1. No, you don't need to write this way, waste time. Below helium, what is there? Neon. And how many electrons? You have taken care of these electrons. Instead of writing 1s2, 2s2, 2p6, simply write neon. After neon, what is there? 3s1. Now you know, in the case of sodium, potassium, helium, neon, argon. 4s1. Then helium, neon, argon, krypton. Krypton nucleus, 5s1. Xenon nucleus, 6s1. Radon nucleus, 7s1. That's all, finished, over, electronic configuration. Otherwise, no, 8 to 7. You see, find out how many seconds you take, go home and try it. And writing correctly, that is also important. Writing electronic configuration 8 to 7 without referring to that, definitely you will commit some mistake somewhere. So, this is the condensed electronic configuration. Does it tally? Yes. There are 2 electrons here, 10 electrons here, 18 electrons here. This is 10 electrons here, 18 electrons here. This is going to be 36 electrons, 54 electrons, 54 plus 32, 86 electrons, 86 plus 1, 87. We have assumed. What is it going to be? 36 plus 1, 37. What does it matter? How are we going to account for 37 electron? Instead of writing individually, you can write krypton, nucleus and 5s1. That is why the general electronic configuration is taken as ns1. General electronic configuration represents the electron present in the last shell. Let's see. Fluorine, chlorine, bromine, iodine, astatine. Astatine. Did you include astatine? Tell me the atomic numbers. No, wait. He is mentioning it. 9, 17, 35, 53 and 85, add 82, 32. Therefore, let me first put this nucleus, helium, otherwise we might forget. I know the order: helium, neon, argon, krypton. I should have xenon nucleus, and then let me also include the atomic number. We should be able to tally. We should be able to tally. Fluorine, chlorine, bromine and iodine. Yes, this is going to be neon first. 1s2 is taken care of. So after this, what should you write? What did you write? You tell me. You tell me. Yes? No, no, no. The electronic configuration: helium nucleus, 2s2. Did you write that? Now what did you write? Okay. You lost there. What should be this? Neon? Be seated and tell me. What should be? What have you written there? Look at your notebook. 3d5. 3d5. There is no s electrons? 3s2, 3p5, ns2, np5. Thambi, so what did you write for bromine?
3d10, 4s2, 4p.
It's not simply 4s2, 4p5. Why did you 4s2? How many of you, be seated. How many of you written bromine is equal to argon nucleus 4s2, 4p5? Raise your hand. Nalla thukkanum, appadan theriyum enakku. 4p5. We will verify the tally the number of electrons. How many electrons are there? That is why I told you it is 2 electron here, 10 electron here, 18 electron here, 36 electron here, 54 electron. You should be able to count 2 plus 7, 9, 10 plus 7, 17, 18 plus 7. What is 18 plus 7? 25. But bromine has got, we have to account for 10 more electrons, isn't it? Therefore, those 2 electrons must enter into 3d orbital. Therefore, the condensed electronic configuration of bromine is argon nucleus 3d10, 4s2, 4p5, 18 plus 10, 28, 30, 35. That is why I asked you to write the rare gases with the atomic number. You should be able to, because you should have definitely, those who have committed a mistake, you would also commit same mistake over here. You would have written krypton and 5s2 and 5p5, but that does not tally with this 53, and I should have accounted for 10 more electrons. Why should those 10 electrons go to 4d10, the previous orbital, as per the Aufbau principle? Now you count 36, 46, 48, 53. What should be the xenon? I mean astatine. Xenon core? It's called xenon core. Core, C-O-R-E, core. It is going to be xenon core. Then tell me. As usual now, you would have tempted to say it is 5d10, 6s2, 6p5, but we have to add all this electron. You have missed some 14 electrons over there, difference. That 14 electrons should go to the 4 of 14. How many of you have written this structure? Raise your hand now after listening to this. This is the cusp electronic on. You add now 54 plus 14 plus 10 plus 2 plus 7, it is equal to 85. This is the condensed electronic configuration. Now I will ask you another IIT question based on this. Are there any question you want to ask me? Yes.
Why do we use only rare gas?
Why do you?
Use only rare gas for the...
That is called the core. Instead of writing 1s2, 2s2, 2p6, 3s2, I write this. When I write helium nucleus, I have taken care of 1s2. By writing the neon nucleus, I have taken care of 1s2, 2s2, 2p6. Same way, whatever the electronic configuration, after 54. After that, as per the Aufbau principle, this is how it should have gone. You go and check. the Aufbau principle. We have written it correctly. Okay. So, instead of writing the entire thing in a very long way, we are writing a condensed, because I do not need the electrons present in the earlier alphabet here. I need to know the electron present in the last shell only, the last shell 7 electron, that too the last orbital is 6p5. I am more interested in that. Then probably I might take care of this, I might take care of this after some time, I might take care of this also in order to account for a peculiar property of that astatine. I need to know only these structures, orbital structure. I am not at all interested any other electronic configuration earlier. That means that is called xenon core. This is what is known as condensed electronic configuration. Now I will ask you an IIT question. Let us see. Shall I ask you an IIT question or NCERT question? NCERT question. Okay. I will ask you an NCERT question. How many, who wants to answer the NCERT question? I will choose. Raise your hand. Who wants to answer? Everyone. Everyone. Thambi, shall I ask you? How many unpaired electrons are there in halogens? It is below our dignity to answer that all of them have got only one unpaired electron. When you say 5 ns to np5, there is only one unpaired electron. What should be the valency of all the halogens? There is only one. What should be the formula of the hydrogen halide? HX only, HF, HCl. What should be the formula of the oxide? What should be the formula of the nitride? I can go on with that. What should be the formula of the sodium halide? It is going to be NaX, NaCl, NaBr, NaI. These are the NCERT question. Now I will ask you the IIT question. Let us see. Raise your hand, buzz around. What is the general electronic configuration of halogens? I told you it is an IIT level question. Saying an NS2 NP5 is an NCERT question. That is an NCERT question. What is the general electronic configuration of halogen? It is going to be NCERT question if you say NS2 NP5. No, we have come much away from that. How can this be n here if you say n is equal to 6? If n is equal to 6, what is this value? N minus 1. What is this value? N minus 2. What should be the electronic configuration? N minus 2 F14, N minus 1 D10, NS2 NP5. Write it. Purida, is that clear? If this is n, n is equal to 6, what is 5? N minus 1. What is 4? N minus 2. General, they do not have electron n minus to F14, that is all. In general, the halogens, we do not have d orbital in the case of chlorine and fluorine. We have to say 0, n minus F0, n minus 1 D0 for a particular specific halogen, because there is no need for the d orbital. If n is equal to 3, what are you going to say? N minus 1 d equal to 0. You have to write n minus 1 d equal to 0, ns2 np5. Therefore, ns2 np5. Is that clear to you?